So I've had a number of people request that I do a video on electromagnetism, especially with respect to clockwise and anti-clockwise. I understand even when I was in high school, I used to struggle a little bit with that topic as to what it meant. So I have equipment here that I hope is going to help in terms of understanding what is it that I'm talking about, right? So let me just label what is it that I have. I have a solenoid. So how you make this solenoid is that you can just have like a wire, a copper wire, and you also have a nail, and you just wrap that copper wire around the nail to make your own solenoid. In this video, I'm not going to talk about the solenoid. I'm going to talk about the straight current carrying wire. So I'm going to talk about this, right? So if we have a wire, a normal electrical wire that you can find all over your household, it's straight. I've tried to make it straight. Hence, they say it's a straight current carrying wire. Why? Because if I connect this, let's say I connect this, I have a power source, that's a battery or a cell. You have the positive terminal, you also have the negative terminal. And I connect, let's say I was to connect it, I'm not doing it right now, I'm just demonstrating connected one end of it to the positive terminal, one end of it to the negative terminal. Then you actually have a flow of charge in your wire from the positive, that's the direction of current, conventional current. So you have that flow of charge or current that is flowing from the positive terminal to the negative terminal. So if this wire has current in it, I would call it a current carrying wire, or in some books they would say it's a current carrying conductor, right? Next, I then have a compass. So the nice thing about a compass is that it always points, it tells you the north pole. So that tip there, that red tip, is it red or purplish tip, points in the direction of the north pole. So, and then I have a bar magnet. Let's see, my bar magnet has the north and the south, the north, the red, the south, the blue. And if I take this magnet, I put it here, you see that the north pole will repel this north pole, hence the tip will be pointing away from the north pole. If I change it all around, I put the south pole here, this south pole will attract the north pole of this compass needle, and they will this compass needle pointing towards the north pole. So essentially, without explaining a lot, the purpose of a compass is just to detect a magnetic field and then tell us which direction is the north, right? Why is that important? A long time ago, a scientist did an experiment. They connected a wire somehow, let's say from the positive terminal to the negative terminal of a power source, and then they put this wire next to a compass needle. And when they did that, they realized that there was a deflection. The tip of the compass needle deflected a bit, indicating that this compass needle was actually feeling a field around this bit. It was sensing something there. This told us, or this told scientists one thing, that around this current carrying wire, there's actually a magnetic field, right? So that is interesting. So where do we come in physical sciences? In physical sciences, we come in here, whereby now they will ask you, tell us the direction of the current or the direction of that magnetic field around this current carrying wire, or a straight current carrying wire. Let me zoom out a little bit so that you can see. Just going to take all of these things out of the shot so that they don't distract me, even the compass. So in your books, just to try to explain this whole concept of the direction of the magnetic field, the direction of the current, we use a pen. So take a pen at home if you have, on one end of the pen, maybe at the back, just cut a piece of paper and you spread and draw a cross around it as I've done, right? And then in front, you don't have to, but it's just important to realize there in front, we have a sort of a dot and around surrounded by a circle. So on this one end, we have a cross or an X. At this end, we have a dot and a round circle. A circle with a dot in the middle. Yes, that is the English, right? So we're going to use this pen to represent a current carrying wire, because if you're writing an exam or a test, you can't be walking around with this, right? That's the first thing. So I'm using my pen to represent the straight current carrying wire, right? And I have the X and the dot. So what is the next thing that you need? You just need your right hand. If you can move it like this, you hold your current carrying wire using your right hand. That's why they talk about the right hand rule, right? So your right hand and a pen, that's all you need to understand this whole concept of clockwise and anti-clockwise, especially for a straight current carrying wire. For a solenoid, we're still going to use the right hand rule, but it's slightly different. I will talk about the solenoid in the next video, so keep on the lookout for that. So there we are. So we have two things. They talk about clockwise and anti-clockwise, and then they talk about into the page and out of the page. Just assume this is the page. So the current can either be going into the page or out of the page. That's as simple as it is. If you have a book, the current can either be going into the page or out of the page. That's it. And then when we talk about clockwise and anti-clockwise, that is just a typical convention that is used. So for example, if you think of a watch, those analog watches that most people don't use nowadays, you have 12, you have 3, you have 6, you have 9. So the direction in which the hands of the clock travel is typically from 12, 3, 6, 1. So it's going in this direction. So we know now that this direction is the clockwise direction. Clockwise direction represented by that arrow that is pointing, it's curling around it. That is the clockwise direction. The opposite, if it's going like this, it's called anti or counterclockwise, because it's against the normal clock direction that the hands of a clock travel in, right? Let me take this out of the shot. So you have a right hand. We have two things. You can be holding a current carrying wire. The thumb of your right hand represents the direction of the current for a straight current carrying wire. For a solenoid, it's slightly different. So for a straight current carrying wire, the thumb represents the direction in which the current is traveling. So the current can either be traveling out of the page, because this direction is facing out of the page towards you, or into the page. So where my thumb is pointing down, out of the page, into the page. So if it's going out of the page, we represent it with a dot. See right there, out of the page, represented with a dot. So it means if it's out of the page, my pen would be facing in this direction, but I will be using my right hand to hold it. The direction is pointing like this. The thumb is pointing out of the page. So you see there's a dot, it's moving out of the page. Look there at the tip of your pen. You have that dot there in the middle with a circle. It's not as clear, but that's where it comes from. You have a dot and a circle, and you see there you have a dot there in the middle and a circle around it. So it's out of the page. You can also have a scenario where the current is going into the page. In that instance, we represent it with an X. So if it's going into the page, we turn our pen around And what do we see? All of a sudden, we see that X. So it's going into the page. It means I'm going to be holding this thing like this. It's going into the page. My thumb, you see, it's pointing into the page. Let me do this quickly. My thumb is pointing into the page. There's my thumb is pointing into the page. And what do you see? You will see an X. So it's going into the page. You represent it with an X. So current direction can either be out of the page, into the page. What about the direction of the magnetic field? If the current is moving out of the page and I represent the current like this, my four fingers represent the direction of the magnetic field. So my fingers can either be clockwise or anti-clockwise. Clockwise or anti-clockwise. So if it's moving out of the page, where is my fingers? In which direction are my fingers curling? Are my fingers curling clockwise or anti-clockwise? If they are going this way, they are going against the clock. It means that they are going, it's going in the anti-clockwise. So look, it's going into the anti-clockwise direction. So when the current is going out of the page, so a dot with a circle, my magnetic field is going anti-clockwise. I hope you're able to see that. If now the situation is different, my current is going into the page, the X, the dot and the X is going into the page. What then do you have? You have, that's very uncomfortable position to hold. But now you have your current, your magnetic field are going in the clockwise direction like that. The current is out of the page and your magnetic field is in the clockwise direction, right? So you have those two cases where you have magnetic field is going into the clockwise direction and your current is into the page. You have where your magnetic field is going into the anti-clockwise direction and your current is moving out of the page. So into the page clockwise, the magnetic field. Out of the page, your magnetic field is going clockwise, right? If that is clear, we can then just, if you are asked to draw this situation, because you're not going to draw all of these things, you draw this situation, you say, okay, this is into the page. Look at the direction of my magnetic field. You draw that circle in the middle with an X and you draw the direction of the magnetic field around it and it's in the clockwise direction. But if the current is out of the page, a dot, a circle in the middle, and you know that the magnetic field is going out of the page, into the page, out of the page. I hope that is slightly a bit clear. I think where people then would get confused is that when we talk about a solenoid, the thumb is no longer the current, but now the thumb is actually the direction of your magnetic field. And this is the direction of the current. But I will do that in the next video. So just remember, have a pen. One end put an X, and then at the other end of the pen at the tip, you have a dot with a circle. So then you have either into the page, you curl your right hand like this. So your magnetic field is going in the clockwise direction. Your current is going into the page and you seeing an X. If it's out of the page, your current is going out of the page, you will see a dot, but your magnetic field will be going into the anti-clockwise direction.